Welcome everyone to the first lightning talk of today. My name is Anton Michaels. I'll be presenting atom, shading, and material modularity. First, just to present the problem, in Atom, the renderer, we want to render many different kinds of materials: skin, fur, cloth, vegetation, car paint. And to accomplish all these, you need very specific shading models, or BRDFs as they're known. To accomplish this, depending on your renderer, there are different ways. If you're a deferred renderer, you would generally need some kind of per pixel ID. This could be a material or a triangle ID. You would then need to run several passes, one for each of your shading models that you want to render. And this indirection adds a bit of complexity and also an efficiency, although there's some optimizations that can be done. I have a link at the end of this talk with different presentations from other talks in previous SIGGRAPHs. If you're a forward renderer, you don't need to worry about this ID indirection. Shaders just work. You resolve the shading model directly in your forward shader. This lack of indirection keeps the code simple. Unfortunately, it does result in shader permutation increase, and the quad inefficiency and bloated forepass are also performance issues. We're currently working on resolving these in Atom. So Atom's Forward Plus pipeline, we chose Forward Plus because it allows more flexibility for artists and also modularity for game teams. So if you have complete control over your materials and shading models, you can easily adopt a cartoon renderer, a physically based render, something in between. The door's wide open for creativity. And modularity, because materials don't need to know about each other, so you can easily add new materials without impeding on existing architecture. The problem with this, though, is that it results in code duplication. So I'm going to go over the problem. What I'm going to present is this old pseudocode. It's not actual code lifted from Atom. So here's a material shader. It starts off by setting up a couple parameters: your normal, your color, your roughness of the material. And then we have our lighting accumulation floats. So we want to accumulate diffuse and specular lighting. We run the light loop, which is accumulate lights function. And then at the end, we output the render target. So we're going to dive a bit deeper into this part, which is the light loop. So in our light loop, for each of the light types, we apply the specific lighting function. And then if we dive further into this lighting function, we first set up the light, so direction, intensity, other parameters you need, and then we actually call our shading model functions, in this case diffuse and specular lighting. If we dive into these, we have our actual shading model, which is defined by Lambertian diffuse for diffuse, and then GGX for specular lighting. And the problem is that the shading model here is defined by the material shader. So if you have a material, a skin material or a hair material, you want that to define the shading model. But unfortunately, you're going to have to duplicate this lighting code, the light loop and light functions, and that's quite a bit of waste. Other programming languages that are not shading languages usually have some kind of function pointers that can be like virtual functions that you override. But this is unfortunately not an option with shaders. So the way we accomplish this, the way we avoid this code duplication is with some include magic. First, as a brief note about AZSL. AZSL is Amazon Shading Languages. This is our extension. Under the hood is basically HLSL with a bit of syntax added. The way this include magic works is this light loop .AZSLI will use functions that are defined in my custom BRDF. And so if you want to make a second material, you can just include your second my custom BRDF that defines the functions that are needed in the light loop, and it will just work. One downside to this is that the include order matters, and if you try to include light loop.azsi without first defining the functions, you'll fail to compile. So the way the customization works is we have 4 customizable pieces. First are 2 functions, the get diffuse lighting and get specular lighting that I've already mentioned. And then we have 2 additional classes, surface and lighting data. So here again is to highlight the 2 custom functions that you define. In Atom, these look a bit more like this. So you have get diffuse lighting, get specular lighting. You'll have your shading model here, so diffuse, Lambertian for diffuse, and then GGX for specular. And here are like the custom classes that we define. So we have a surface and structure and a lighting data structure. What these look like: surface is just your surface parameters, so the position of the surface, the normal, the color, the specular, and the roughness values. And for the lighting data, we have our light tile iterator, we have the diffuse and specular lighting that we're going to accumulate throughout the lighting function. We have translucent backlighting that we also accumulate. And then we have a couple of helping values like direction to camera, normal dot view, emissive lighting, and scattering compensation. These are just pre-calculated because they don't change from light to light. So now if we go back to our material shader with the updated view, we have our custom classes that we define here. We set them up, and then we pass them on to accumulate lights. If we now dive deeper into the light loop, we have our accumulated light functions that takes these two structures. So they're passed through. These are then, again, passed through into the lighting function, same custom classes, all the way down to the shading model. And so these get diffuse and get specular lighting functions now take in your custom classes, and you can do whatever custom logic you want with the extra parameters that you added inside. So as an example for this, we have our skin surface and skin material. For skin, we want to render a second specular lobe to get that kind of a oily look that you have on the surface of your skin. And so we define values to calculate a second specular lobe. So we add this to our surface. So this would be in like the skin surface.azsli. Structure is named the same, skin surface. And for lighting data, we don't actually need to define anything else. So we just need to customize the surface structure. And then here, again, in our specialized skin lighting code, it's fairly similar to the previous one, except that now we add a second specular lobe to the output of the specular. And this is one of the results we have. This is one of the game teams that we're working with. Has this undead character, and we use the dual specular lobe on his skin. And here are the references to two of the talks. One is how to do different materials in a deferred way, and the second is how to do it in a very forward plus way that I referenced earlier in my presentation. That's all. Thank you.